So hey guys, welcome back to my channel. Hope you're doing extremely well. And I have come up with the GFG have come up with the new problem of the day, and I would say that it is a very good problem. Like I have to reconcile it. How can I solve it? How can I solve it? Because the time complexity for this question is the one which was a challenge for me also, and that is why a good company like Google has also asked for it. So let's see what is the question saying. So the question says, suppose you have an array as 2, 7, right? You have been given an array, right? And you have to tell me the sum of bit differences. As in, if I represent 2 in binary, what would it be? It would be 0, 1, 0, right? Right? And if I represent 7 in binary, it would be 1, 1, 1. Are we on the same page? Yeah. So the question says me form all the pairs. The question says me form all the pairs. As in, one pair can be 2 comma 2, another pair can be 2 comma 7, another pair can be 7 comma 2, another pair can be 7 comma 7, right? Okay. These are the four pairs possible. So what are the number of pairs possible? Number of pairs possible is, suppose the length of the array is n, so I have to take pair, right? Two possibilities. Here also n elements can come. Here also n elements can come. So n square different possibilities. N square different pairs can form. Okay. Now if I see the binary representation of 2 and 7, I see that what are the bit number of bits which are different. Like this is 0, this is 1. So 1. This is 1, this is 1. It will remain 1 because all of both of them are equal. But 0 and 1 again change. So it will change to 2. So I would say the difference between the number of different bits in 2 and 7 is 2, right? For 2 and 7. Can I say the same thing for 7 and 2? Obviously correct. For 7 and 2 also 1 0 1 1 1 0. So it will be given 2 here, 2 here. Talking about 2 comma 2 and 7 comma 7, that is the same element. So 2 comma 2. 2 is 0 1 0. Again 2 is 0 1 0. Are there any bit difference? Is there possible that the bits are different some at any position? No, because the number is same. So in that case, whenever you encounter similar elements, it will return 0, it will return 0. Okay, we have to count the number of different bits, number of different bits. And whenever I say different bits, as a software engineer who is practicing DSA, your minds to strike XOR, right? Binary, which is represented as this bitwise XOR. So my task has been simplified due to XOR operator. What will XOR do? So XOR will do, like I have got 0 1 0 is 2, right? And 7 gives me 1 1 1. So XOR, the operation for XOR is whenever you encounter different, replace it with 1. So 0 1 will give 1 1. 1 1, whenever you encounter same, make it 0. So 1 1 will give 0. Again 0 1 is different, so 1. Okay. So what is the number XOR is providing me? So XOR is providing me with a number, it returns 1, that is 1 plus yeah, 1 plus 0 plus 4, that is 5. Yeah, answer in the comments if it is correct. It is representing 5. Okay, now the task is to calculate the number of set bits, number of set bits in 5, number of set bits in 5. For that I have got two approaches. Either I can manually write the code for set bits, manually write the code, right? Or I can use the inbuilt function, right? I can use the inbuilt function. So I will show you the inbuilt function to calculate set bits. So it is known as built-in pop count, right? If you go here, you will be able to see a C++ built-in pop count function. This function is used to count the number of set bits in an unsigned integer. In other words, it counts the number of ones, sorry, in the binary form of a positive integer. I think the definition is pretty much clear. I don't need to elaborate it. It will say that if I use the built-in operation or this one, it will represent me. It will give me 2 as my answer. And wanted that only. If you can see the difference in number of different bits in 2 and 7 is 2. number of different bits, set bits in 5 is 2, so I can use this value, right? The answer will be solved. So what has my approach come to? So my brute force approach, this was my brute force approach, I was explaining this from my brute force approach and generally also. So my brute force approach is, suppose I have an array of length n, so I will move my I from 0 to n minus 1, and because I have to select all the pairs, what I will do is I will also start from 0 to n minus 1, right? Okay, after that what I will do is answer plus, suppose I have implemented my answer equals to 0 here, I will do answer plus equals to, I will use a built-in pop count, that is the inbuilt library, and what I will pass here is I will pass a of I xor a of j, right? And at last, after this outer loop is finished, I will return answer, right? So I don't think that this process needs a dry run, it is pretty basic. But what is the time complexity? So you can see this is running n times, this is running n times, so it is will be O of n square. And I don't know about the time complexity of built-in pop count. You can check on the CGFG link only. I will attach it in the description. Okay, O of n square time complexity. Space complexity O of 1, because we are not storing anything, right? We are just using variables to keep track of the problem we are moving. Okay. Can we optimize it? Can we optimize this? So the answer to that will be yes. What I will do is, suppose I've got 2, 7, right? 2, 7. What are the possible pairs? 2, 2, 2, 7, 7, 2, 7, 7. So instead of moving j from 0 to n minus 1 altogether, what I will do is, in the above approach, I will move from 0 to n minus 1. J will move from I to n minus 1, right? And instead of incrementing by this value, I will just twice it. So answer plus equals to 2 star and the same expression built-in pop count, and at last return answer. So what is happening is, so it will be running from I equals to 0, then it will run for I equals to 1. For I equals to 0, j will be 0 first and then 1, and for I equals to 1, j will be uh, 1 only, right? So for 0 0, that is 2 comma 2 is a pair, right? Now you will see that 2 comma 2 is coming only once in the all the pairs, but you are multiplying it by 2, so you are incrementing twice, you have to decrement also. I will say that I don't need to. Why don't I need to? Because 2 comma 2 is anyway returning 0 because it is same. So if I add 0 or I add 2 into 0, I'm essentially adding 0 only, so I don't need to worry about that. Okay, other pair is 0 1, so that is 2 7, right? Now this pair is 2 7. What is let's suppose the answer to that is x. We have calculated it, x is 2 here. Okay, is 7 2 also returning 2? Yes. So instead of incrementing only 2, can I increment 4? Yes. So it will be incrementing 0, it will be incrementing 4, that is 2 into 2. Okay. Moving to 1 comma 1, that is 7 comma 7. Again 0 into 2, that is 0. So my answer to that question will be 4. Okay, and okay. So but the time complexity is still not increased because it will be moving O of n times, and it will be moving first, it will be moving for n steps, then it will move for n minus 1 steps, etc, 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 etc. And I have explained in my previous videos many times that this complexity is also O of n square, right? You can watch that. Okay, now essentially we have reduced some computation, but the time complexity is big of n square, so we have not gained anything from the efficient solution also. I have to use another approach, right? So I'll say that forget this approach completely. Forget this approach completely, and let us move to the optimized approach, which attracted you to this video, right? This is the main objective to watch this video, to learn something, right? Optimized approach. Okay. So let us change the example. Let us take an array of size 3. Let us take 1, 3, 6, right? 136. Let us first compute the answer accordingly, and then we will check is our approach correct. So 136, right? 136. uh, if I represent 1 as, it will be 0 0 1, 3 it will be 0 1 1, 6 it will be 1 1 0. Please give it a check before proceeding. I think that you should be well versed to solve the binary equivalence up till now. Okay, so 136. 1 1. Okay, obviously diagonal elements will be 0, right? Diagonal elements will be 0. Why 0? I don't think that needs to be explained because I already explained that whenever you encounter two same numbers, in that case, no set bits are different, right? Okay, 0 0 0. Okay, talking about 3, 1 and 3. So this will be mapped to 3. So 1 into 3. So if I can see 1 is equals to 0, 1, no increment. 0 is not equals to 1, so increment. So it will be returning 1, right? 1 and 6, 1 and 6. So change, change. So 3 it is returning, right? Is 3 and 1 equals to 1 and 3? Yes. So change it here. Like it is a symmetric matrix, right? It is a symmetric matrix, right? Talking about 3 comma 6, so 3 comma 6, so it will be 1 1 only and 2, right? So it will be running 2. Talking about 6, so it will be symmetry matrix, so 3 here and symmetry matrix 2 here. So if I sum all the values of this matrix, I will get my answer. It will be 1 plus 3, that is 4, plus 1 5, plus 2 7, plus 3 10, plus 2 12. So our final answer should be 12. Now let us move to the approach which we attracted here. We have got a final answer. We will use our approach and then match, are both the approaches running the same answer? If not, we have considered some error. Okay. So the approach is, as I mentioned, this 001, 011, 10110. I will deal with this. Okay. So one is 001. Okay. I'm writing it enlarged. 011. Right. 110. These are my representations, correct? These are my representations. Okay. My process will say, if you can see here, it is saying array of I is less than 10 to the power 5, right? Array of I is less than 10 to the power 5. So that is my array of elements is implemented in 2 to the power 32 bits only, right? In 2 to the power 32 bits only. Each binary representation will be represented in 2 to the power 32 bits, not more than that. I don't have to go beyond that. Okay. What I will do is, if I move here, if I focus on this column, if I focus on this column, I'll say my total n is 3. I'll say count the number of set bits. Count the number of set bits. Let us count at set bits, right? Set bit stores. So what are the number of set bits here? It is 1 plus 1, 2, right? Unset bits. See, I have got n. I have got set bits. So what are my unset bits? Unset bit is 3 minus 2, right? That is n minus set bits, which is equals to 1. Any problem up till now? Are we on the same page? Okay. We are on the same page, right? So my approach says, if I take these two, if I take these two numbers, will this column give me any answer? Will increment my answer? Obvious answer no, because 1 1 similar. If I take this column with this column, 1 0 incrementing my answer. So this is a valid representation. If I take this column with this column, right, 1 0 again incrementing my answer, correct? So I have got uh, I have to take pairs, right? I have to take pairs. So one value here, one value here. I'm saying that for an increment, this value here should not be equals to this value here, right? If it is 0, it should be 1. If it is 1, it should be 0, right? So I have got my set bits. So if I place 1 here, if I place 1 here, so what are the total number of ways? See, I am using a type of PNC, permutation combination. Okay. If I have to fill this place with a number whose set bit is 1, whose bit is set, right? Whose that bit particular bit is 1. How many ways I have? I have 2 ways. Okay, fill 2 here. Okay. Now, because I want, if I fill it with 1, I want 0 here. To wanting 0 here, I will have to fill it with unset bits. How many ways are there? That is 1 only, right? So into 1. So what are total number of ways? 2 into 1, right? This case is solved. Talking about this case, 0 1. Is the answer 2? 1 0 same as 0 1. Yes, because if I put 0 here, it will be 1. If I put 1 here, it will be 2. 1 into 2 is 2. You can check. So my total number of cases is 2 into 2. 2 into 2 into set bits into unset bits. Right? Any problem up till now? Any problem up till now? Right? Any problem up till now? No problem, right? Okay. So this will be my algorithm. This will be my algorithm. I will count the number of set bits. I will count the number of unset bits. I will just multiply 2 into set bits into unset bits and then increment my answer accordingly. And I will return at last. This is the whole algorithm. How many times it will work? It will work for 32 times because we know that in the int, maximum bit count will be 32, right? In the interval 32, all the bits will be done, right? Okay. So let us try run this. Let us see if it is matching our answer which we calculated here, that is 12, right? Talking about this column, we just saw set bits are 2, unset bits are 1. So my answer was particularly 0 first. It will convert it 2 into 1, which is 4. So my answer will get converted to 4. Talking about this column, my set bits are 2, unset bits are 1, right? You can see set bits are 2, unset bits are 1. So again, 2 into 2 into 1, which is equals to 4. My answer will change to 8, right? Talking about this column, set bits are 1, unset bits are 2, right? It will also change 2 into 2 into 1, which is also equals to 4. And 4 plus 8 is 12. Our loop will end, like it will go up till 0 0 0 0 0, but the answer will be 0 because all the set bits are 0 there. Okay, 12. Is it the final answer? Yeah. Is it matching this one? Yeah. So that means our approach is correct. Now, what is the time complexity? Time complexity is we will be using an outer loop which is running 32 times, and we will be using an inner loop to count the number of set bits which will be in running n times, right? All the array elements. So 32 into n. So it will be O of 32n as time complexity. And what is the space complexity? O of 1, because we are not using any extra space, right? So it is essentially O of n only, right? You might be knowing this because of the big O notation, the constant gets deleted. Okay. Any problem, guys? Any problem? What did we do? We counted the number of set bits, we counted the number of unset bits, 2 into set bits into unset bits, and move it 32 times. Right? The concept that how will you get that if the bit is set or unset is actually studied during the bitwise operations, and we will be studying that code also. We will be definitely using the shift operators, the shift operators. Okay, so I guess it is enough of the explanation of the algorithm. If you're liking this video, do not forget to like the video and subscribe to my channel. And we will move to the code now. We will move to the code now. So okay, coding it down. First of all, what do we have to return? We have to return a long num type variable. Let us name it first. It is as answer equals to 0. After that, our outer loop was working 32 times. So for int I, going from 0, going up till 32, I plus plus, right? So let's say int set bits is equals to, let us name it as count only. Count is storing the number of set bits, right? Count is currently 0, right? We will move for the all the elements. So for int j equals to 0, j less than n, j plus plus. What are we doing? If that element and 1 left shifted to by I positions is returning 1, in that case count plus plus. For those of you who do not understand, just stay with me. I will tell you how it is working. And after the loop, answer will be incremented by 2 into count, that is number of set bits. What was the number of unset bits? It was n minus count, right? It was n minus count, right? And just it is the answer. And at last, return your answer. Let us see if it is working fine. And if you have not understood this, just stay with me. I will be explaining in the code, noting down area. Just stay with me for a minute. It is returning 0. Why is it returning 0? There has been some mistake, guys. uh, oh, it should be if error of j. I got the error. Let's see if it is working fine now. Because error of j we have. Okay, it is working fine, so let's try to submit also. Hope it works. And oh, there has been an error. Oh, I got the error. We have not converted this count into long type. We have not converted this count into long type. So what we will do is we will say 2ll, that is convert into long type, right? And then convert this count into long type. That is just sub typecasting. That is why it is the only thing I don't like in C++, right? It is the only thing that I prefer Python sometimes. Hope it works now. No syntactical error, I guess. No syntactical error. It will work now, I guess. Yeah, you can see the meter going up very. So you can see 76 days has been completed. But stay with me. I know many of you have not understood what is this if condition doing. Array of j and one star I. Sorry, arrow I. So suppose my number is 7, right? ARR of j is 7, so it is represented as 1 1 1. And I was saying that we have to do the column, right? We have to do the column. So suppose we are on the this column, that is the uh, what do we say, second column in the sense. Okay, and my I is like if I have to go here, my I will be 1, right? Because we are starting from 0. Okay, I have got 1 with me. Now, it 1 is actually in binary, it is 0 0 0 0 0 up, then 1, right? 0 0 1, right? For this one, for this one, how can I get if it is set? So I will use an AND operation. AND operation. What will AND operation return? It will return 1 only if this and the corresponding one is, both of them are set. Okay, what I will do for that, I will have, my one is actually currently here. I will have to move it here. So what I will do is I will left shift by how many? I have to left shift by one only, that is I. So what I was doing is one, oh I, so one left shift by I was giving me this 1000, right? And if this and this is 1, that means this is set, and in that case count was getting incremented. Okay, so if you have any doubts left, please comment in my section, comment in the section below. I will surely get back to you and I will try to solve your doubt. And this was all from my side. You can see we have completed. What is the current streak? Let us see. It is 76 days. I have not refreshed it yet. Okay, 76 days, and it has been a long journey. We'll meet tomorrow with a new question and a new energy. Till then, please keep watching and stay connected. Thank you. Have a nice day.